All right, well, today we're going to be forging into new territory with section 10.2, angles of rotation. And first we'll start with our question of the day. What do you call a math teacher who takes his vacations at the beach? And the answer is, oops, what part is there? It is a tangent, or a tangent. It's one of my favorites. All right, so first we're going to start by discussing standard position. Okay, so what we're going to do is we're going to have the full coordinate plane. And when you label, this is going to be angles, so when you label it, we always put 0 on the positive x-axis. And then remember in geometry, positive angles were counterclockwise. So if you go counterclockwise, you actually had a positive angle. And then if you went clockwise, it was negative. Well, when we set up our axis, we're going to make these positive. So if I start at 0 and I go counterclockwise to here, how many degrees have I gone? Well, that's going to be 90. Sorry. Then I'm going to keep going clockwise, or counterclockwise I meant. I'm going to keep going counterclockwise to here. Another 90 degrees will put us at 180. Then I'm going to go another 90 degrees. That'll be 270. And another 90 degrees, I get back to where I started, which is also 360. Now, you can imagine you could just keep going. You could go around another 90 degrees and get another coterminal. Oh, I'm using words we don't know yet. Sorry. Let's see, what is 360 plus 90? That is, my brain is really slow today. That's going to be 9 times 5, 45. So this would be, that doesn't seem right. Here. Sorry about the slowness. Yeah, that's 45. All right, 450. You don't need to write this down, but I'm just trying to kind of help you see it, that if you just keep going around and around and around, you can have various labels for each of these positions. Since it's infinitely, you can go around infinitely. But I'm going to erase that because we don't typically label it like that. We just leave it like that. So standard position would be if we took our angle, and we how an angle has two legs. One of the legs will always be on the positive x-axis if it's in standard position. And then the other, so that's called the initial side. The initial side is always on the positive x-axis. And then if it's a positive angle, then we would go counterclockwise and say we went 110 degrees. Well, that'd be 90. That would be 90 plus 20, right? So we could go to 90, and then we could go another 20 degrees, and this would be our angle. So this is the terminal side. So the initial side is always on the positive x-axis, and then the terminal side is the other leg. And if you're going in a positive direction, or if the angle is positive, we go counterclockwise. And if the angle is negative, we are of course going to go the other way, which would be clockwise. Okay, let's see what we have on the next slide. Well, now we're going to draw them. Oh, this is where it helps if you can do mental math quickly in your head. But, well, let's just do this. So anyway, I'm going to draw, please, and when you do this on your homework, draw separate axes for each angle, because if you put them all on one, it's going to be a huge mumbo-jumbo mess. All right, so it's 320. And we always know that the initial side is on the positive x-axis, so I'll go to my orange color here, and I'll start it on the positive x-axis. It is positive, so I'm going to be going counterclockwise. And just since we're new at this, let's put on these angle measures again. So I'm going to start here. I'm going to go around. There's 90, 180, 270. I'm getting closer. And then 320 minus 270 is 50. So that means from here I have to keep going 50 degrees, which is a little more than 45, because 45 is halfway. So about here. And that's where I'm going to have my terminal side. And then when you draw these, please, or we need to, draw an arrow showing where you started on the initial side and around to where you ended, and then put an arrow on it. And then you would label it 320, sorry about that. I looked at the wrong number. So that would be 320 degrees. So this is how we draw this. Okay, we'll go to the next one. This time I'm going to make the, the orange one. I'm going to put B down here. Sorry, I'm going to make the orange one be the axis. Oops, that's not X. Well, it could be, but I want it to be 0. 0, 90, 180, 270. Okay, so we're going to start with terminal side. Initial side at 0, positive x-axis. This time it's negative, so I know I'm going to be going clockwise. And actually, so you have to think, okay, this is 90 degrees to here. It's 180 to here, so that's too far. And if I went to 270, then that's another 40 degrees to 110, right? So from here, I'd have to go 40 degrees. So 45 is halfway, so I don't want to go quite that far. So I'm going to go about to here, probably. And then we'll write in negative 110 degrees. When you're sketching these, try to get them somewhat in the ballpark so that they look close to what they really are. And then we'll go ahead and we'll do letter C up here. This one looks interesting, doesn't it? It's a big angle. 0, 90, 180, 270. And again, we always start the terminal side on the positive x-axis. God, why do I keep saying terminal? Initial side, there. All right, so this time, again, it's positive, so I'm going to be going this way. And I'm going to be going all the way around and getting to here, and I'm going to be at 360, and I still haven't gone far enough. So let's do that. I go all the way around, kind of make it like a snail's shell. And if I do 990 minus 360, that leaves me with 630. So I'm going to have to go all the way around again, another layer there. Subtract 360 from that. That's 7, and that's 270. Oh, okay, well, we know where 270 is, so we can just keep on going all the way around to right there is 270. And then up here we can write 990 degrees. So we have this cool snail shell looking thing. And then show your arrow too. It shows which way you're going. All right, I highly recommend that you pause and do these on your own, and then I will show the results. Okay, I'll do all of the axes first. Just to save your time, I'm not going to label all the angles because you know where they are now. All right, so the first one is 210. So that's going to be here around to 180. And then what? That's 20 and 30 more degrees. So that's about there. And then we write 210 degrees. Okay, this one is 1020. Turns out, and it's positive, so you're going to go this way. 1, 2... I was looking at, and then it goes around again to here, and you end up with 30 degrees left over right in here. So that's what it should look like, and then we label that 1020. And then this one's negative, so it's going the other way. It's not quite 360, so to there's 270, and then you need another 30 degrees. Whoops, further, so maybe about there. And then we write negative 300 degrees. So that's what you're, oh, here, I forgot the arrow. Forgot the arrow there too. I better listen to myself, huh? There's the arrow. Okay, that's what you should have there. All right, next example. Find the measures of a positive angle, and a negative angle that are coterminal. I haven't even talked about what coterminal is yet. I tried to say that word though earlier, didn't I? Coterminal means two angles that have the same terminal side. So I'll just draw a picture of this. 65 degrees, that's more than 45, and it's positive, so it goes this way. So that would be a 65 degree angle graphed. And, oh, let me show you back on this other slide. Negative 300, this one we just did here. is coterminal with positive 60, right? Because there's 60 degrees. This is 300 around to here, and then all the way to here is 360, so there's 60 degrees in here. So if I wanted to graph 60 degrees, I would start here and go this way, and notice they would have the same terminal side. So that means that 60 and negative 300 are coterminal. They have the same terminal side. And a way you can find terminal and coterminal angles is by adding or subtracting 360 degrees. So if I took negative 300 and added 360 degrees, notice I would get 60, wouldn't I? And if I went the other way and did negative 300 minus 360, I would get negative 660. So negative 660 would also be coterminal. In other words, if I started here and I went, let's see, that would be around to 360 and then around to here, that angle would be negative 660. So the fast way to find coterminal angles, if you're given an angle, is to add 360 or subtract 360. And you can do multiples of that. You could add 720 as well, or subtract 720. So you can add or subtract multiples of 360. So in this case, if I took 65 and I added 360, I would get 425 degrees. So that means if I started here and went around 360 plus 65 degrees, I would get 425 degrees. This green one would be 425 degrees, and it would land on the same terminal side as 65. So that's a positive angle that is coterminal. So that's one answer. And then to get a negative angle, we would do 65 minus 360. So that's negative 290. And that would be the negative one. Oh, 390. No, yeah, it is 200. Because I don't trust my math today. It's just awful. If I take away, yeah, 300. Oh, it's my 95, isn't it? Take away 60, that's 300. Take away 5, it's 295. I don't know what's wrong with my brain today. I'm sorry about that. I knew that just didn't seem quite right. Okay, well those are correct now. Oh, let's do this one together as well. Now notice this one is greater than 360 already. So if I subtract 360, I'm still going to have a positive answer here. And like I said, my math, boy, today it's bad. So 50 degrees would be a coterminal angle that's positive. And then I'm going to subtract 360 from that, and that is negative 310. So that is a negative coterminal angle, and this is a positive coterminal angle. So you don't necessarily have to add and subtract. Sometimes you can, like in this case, I subtracted 360 2 times, and I got a positive angle here and a negative angle here. So that's all you have to do on those problems. Now these are ones for you to try on your own, so I will write the answers. Okay, on this one, and I just chose the simplest, the ones that were closest to 88. So I added 360 and got 448. I subtracted 360 and got negative 272. On this one, because it's already greater than 360, I subtracted 360 once and got a positive coterminal angle. And then I subtracted 360 again and I got a negative coterminal angle. Here's another one for you to do on your own. It's already negative, so if I add 360, I'll get a positive. So I'm also going to have to subtract 360 to get another negative one. So if you add 360, you get 240. And if you subtract 360 from 120, from negative 120, you get negative 480. So those are the answers. Now, you could, these are not all the correct answers, because any multiple of 360 would also be correct. So you could have added like another 360 to that. That would be 0, 10, 600. So that's another coterminal angle. That would work as well. Alrighty, let's do reference angles now. So with a reference angle, probably easiest if I just do one. Let's say we're given an angle theta is 150 degrees. So let me graph that on here. And it's positive, so I'm going to go this way. And 150, so that's going to give me, well, here's 180. This is honestly the way I would do it in my head. 180 minus 150 is 30, so I know there's 30 degrees left here. And do you know that that's actually the reference angle? So right to here is 150. This angle right here that's left, in this case, this is just in this case, is the reference angle. This is the reference angle. Let me tell you about the reference angles, certain things that have to be true about it. Okay, reference angles. They're always positive. They're always acute. And one side is formed from the terminal side. So one leg is the terminal side of the angle in question. And the other leg is the x-axis. Always. That's always true. So notice here's the terminal side here of my 150 degrees, and this is obviously the x-axis. So that angle that's formed is the reference angle. Let me show you what it would look like in each quadrant. So in quadrant 1, and we end up forming triangles too, so that's the reference triangle. See how I formed a right triangle here? So this would be the reference angle. I'll call it, how about beta? Beta is another symbol for an angle. So that would be the reference angle in quadrant 1. We already know what it looks like in quadrant 2. It would be here. In quadrant 3, it would look like this. So here's the x-axis, here's the terminal side. And if your angle was in quadrant 4, here would be the terminal side of it, and this would be the x-axis, and this would be your reference angle. So I call that a bow tie. Kind of looks like a bow tie. Your reference angles will be one of these angles on the bow tie. And you just have to kind of take it on a case-by-case basis to figure out the actual measure. Like on this one, I just reasoned, I know it's 150 to here, and I have to go another 30 degrees to get to 180. So you just kind of think about it. We'll do some of these so we can get practice. So this first one, 135, what quadrant will that be in? Well, that's going to be in quadrant 2. So I'm going to go around here to 135, and then this is to 180. So if I do 180 minus 135, I'll be able to find my reference angle. So that's going to be 45. We'll draw it in there. Here's your 45 degree angle. So I would like you, even though it doesn't say to draw the picture, it's really important so you can visualize these. So the reference angle is 45 degrees. That's the answer, but please draw the picture as well. Okay, on this one, what quadrant will negative 105 be in? Well, it's going to be in quadrant 3 over here, because I'm going to be starting and I'm going to be going around. There's 90, and then I'm going to have to go, let's see, 15 more degrees. But this 15 is not the reference angle. The reference angle is 180 minus 105. So that's going to be 75. It's really important that your reference angle, one of the legs on your reference angle has to be on the x-axis. So this one would not work. This is not the reference angle. So then the way I found this one is I also subtracted 105 from 180. So 75 degrees is the reference angle. Okay, this one, 325, what quadrant will that be in? That's a positive one, and it's going to go all the way around to the 4th quadrant somewhere. So it's 325 degrees all the way around. That means to get this missing part here, which is the angle I want, all the way around would be 360. So I have to do 360 minus 325 to get my reference angle. And that would be, I'm not risking doing any of this math in my head today because my head's cloudy for some reason. 35 degrees. So 35 degrees would be the reference angle. So again, see how the reference angle is formed by the terminal side and the x-axis. And then if you drop this down and make a right angle, that's your reference triangle. All right, so these you can pause and do on your own, and then I'm going to write the answers up here. Okay, this one, that's weird. Didn't we just do that one? Oh, we did -105. No wonder it sounds so familiar. All right, well, this one's going to be up here in this quadrant, and it's going to be 75 degrees. This one's, again, it's going to be down in this one. And when you subtract, you do 180 minus 115, and you get 65 degrees for your reference angle. And then this last one is in quadrant 4. You go all the way around here, and you draw this in, and you have 50 degrees left. So 360 minus, but you would do 360 minus 310 to get the reference angle on this one. You might wonder why we're doing all this. It's all stuff you need in order to do trig, basically. You'll see as we learn this. So we're getting the building blocks right now. Okay, now what we're going to do is we're going to look at, again, a graph. And I've got an xy on the terminal side of theta. I'm going to stay in the first quadrant. Not that I have to, but I'm going to. So let's say I have this point, or I've got my terminal side, and let's say there's a point on it called xy. And here's theta. And what I'm going to do is form a triangle. So if this is the point xy, that means I went over x and I went up y, right? Well, this is called the radius, because we're going to think about this being a big circle later on. So this would be like the radius of a circle if you spun this thing around. How would you get this length r? Well, you'd use the Pythagorean theorem, right? You'd do x squared plus y squared equals r squared. And to get r, you would take the square root of both sides. And r is going to be positive because it's the radius of a circle, so we don't need the plus or minus out front. So r is the square root of x squared plus y squared. All right, now we're going to look at the 6 trig ratios on this triangle. Sine, so we'll do sine of theta, cosine theta, tan of theta. And sine is, we know, we'll use SOHCAHTOA because hopefully you guys are getting to where you're remembering this stuff from last year. So sine is the opposite over the hypotenuse, so it's y over r. Cosine is adjacent over hypotenuse, x over r. Tan is opposite over adjacent, which is y over x. And x cannot equal 0, obviously. Okay, then if we want to do the reciprocals, they're not called inverses, that's something different. The reciprocals of sine, that's cosecant. We just do the reciprocal, r over y. The reciprocal of cosine is secant, so that's going to be r over x. And then the reciprocal of tan is cotan, and that's going to be x over y. So those are the 6 trig functions defined in terms of x, y, and r, instead of opposite, adjacent, and hypotenuse. Make sure you write those down because you'll need to know them. And then we're going to practice this on the next slide using it. Over here where I have some space, I'm going to draw or plot -6, 9. So that's going to be in the second quadrant. Back 6 and up 9. Back 6, up 9. -6, 9. Draw a triangle. And it's on the terminal side of theta in standard position, so theta would be this one. The reference angle is right here. It turns out that the trig functions of theta are the same as the trig functions of the reference angle. So we can use this triangle to find sine, cosine, tan of theta. I'm trying to decide how I want to label this. I normally just put theta there, to be honest. I'll just call it theta sub 1. But the sine of theta is the same as the sine of this theta 1. So I'm going to write down sine of theta, cosine theta. We'll keep the nice order that we're used to working with. And then we're going to have cosecant theta, secant theta, cotan theta. So I'm setting up what we're doing here. Now we're just going to use the rules. So sine is y over r. Oh, I went back 6, I went up 9, so I can label that. And then also we need to figure out the hypotenuse. So that's the square root of 9 squared plus negative 6 in parentheses squared. 9 squared is 81, 6 squared is 36. That's going to be 7, 8, 11. Oh, 117. Huh. That's weird. It's kind of a clunky one. 7, 8, 9. You know what? 7, 8, 9. Those add up to a number that's divisible by 3. That means this thing is going to be divisible by 3. 3 goes into 11. You can divide this on your calculator, but I'll just do it in my head. So it's going to be 30. Wait a sec. 3 goes in there 3 times. 9. 27. Oh, 3 goes into 27 9 times. And then divide that by 3, which is 13. So if you rewrite that, you get 3 root 13. Make sure you simplify your radicals. And this book, look what they did. Negative 6, 9, and 3 are all divisible by 3. So because we're doing ratios again, I am going to simplify those, because otherwise I'm going to have to simplify them over here, and that's a lot of work. So I'm saving myself some time. I can only do that if I'm doing the trig functions, because the ratios, they're just ratios. So I'm going to divide each of these by 3. So divide 9 by 3 and you get 3. Divide negative 6 by 3 and you get negative 2. Divide this by 3 and the 3's will cancel and you get root 13. So to make life easier, I have reduced, so to speak, my sides there. So I'm going to be using these blue numbers. I hope that doesn't confuse you. I'm just trying to make it easier for us over here. So sine is going to be here. It's going to be, we're used to doing opposite over hypotenuse, or in this case y over r. It's the same thing. It's 3 over root 13. And then we'll simplify that. Oh, you know what else you want to do, come to think of it? Before you simplify it, do the reciprocal and write it over here. So that's going to be root 13 over 3. Now I'll simplify it. So that's 3 root 13 over 13. And that's the way we want to write that. We want to do the reciprocal of the original one, because if you do the reciprocal of this, then you have to simplify that, because you end up getting a radical in the denominator. Cosine theta. So that's going to be adjacent, which is negative 2 over hypotenuse, which is root 13. Or the new definition would be x over r. Okay, again, I'm going to do the reciprocal of that and write it over here for secant. So that's negative root 13 over 2. And then over here, I'm going to rationalize, because we have to simplify our answers. We get that. Tan is opposite over adjacent, or y over x. So we get this. We don't have to simplify that. Do the reciprocal, and you get cotan. So there are the answers. When you're doing your homework, please put them in this order so that they're easy to grade. I'm just kind of looking. I hope I didn't confuse. I might have confused you by reducing all this stuff down ahead of time. If that's confusing, you can leave them, negative 6, 9, and 3 root 13, and do all the same ratios. You'll just have to simplify it more. How are we doing on time? I have lost track. Because r is a distance, its value is always positive. Yes, that's right. I mentioned that. Okay, and this is the last slide, so I will put the answers up here for you. I do wish our book had been nicer to us and given us values that were, so back 3 and up 6, I'm not even going to care how I plot that. Let's just do this. And then when you figure this out, you end up getting 3 root 5. And see, again, these are all divisible by 3. Oh well. Tell you what, I'll do it we'll do it this way. We'll do it without reducing ahead of time so you can see how that would work. So if you do sine, you end up with 6 over 3 root 5. I have a feeling this is a longer lesson than normal, seems like. Okay, well then see I have to reduce, so I get 2 over root 5. Flip that, you get root 5 over 2. Simplify that, and you get 2 root 5 over 5. So there's your answers, simplified. Cosine is going to be adjacent over hypotenuse. That's going to reduce to negative 1 over root 5. Do the reciprocal before you simplify, which is the same as negative root 5. Simplify this, and you get root 5 over 5, but it's negative. Simplify that. Tan is opposite over adjacent, 6 over negative 3. That's going to be negative 2. Reciprocal, that's negative 1/2. So that one wasn't too bad. All right, we'll see ya. Hopefully there weren't too many beeps. We're trying to fix the problem.